Alright, hi everyone. So for today's lesson, we'll actually be looking at the first part on organic chemistry, which is on the introduction to organic chemistry. So in this part of the lesson, what we are going to take a look at is 5 key components. Firstly, what exactly is a fuel? Second, what are fossil fuels? How are petroleum separated into useful fractions? What are the uses of the different fractions? And lastly, what are the environmental issues that can arise from the use of fossil fuels? So let's get started. In terms of fuel, one thing that you must know at this point in time is to know that fuel is actually a substance which can undergo combustion in air or in oxygen to liberate useful heat energy. So for instance, when you burn something, right, is considered a fuel itself because it can go through combustion and can give off energy. So for such reaction that gives out energy or liberates energy, we actually call them exothermic reaction, as you recall from your chapter on energy changes. So what exactly are fossil fuels? Because fossil fuels are the key components that give rise to organic chemistry. So in general, there are 3 main types of fossil fuels. There's the natural gas, there's petroleum, and there's coal. Okay, but for the syllabus itself, we mainly focus on petroleum. We'll talk a little about natural gas as well. So let's just have a quick introduction into what exactly are fossil fuels and how they form first. Many years ago, when sea creatures and plants they die, right, they actually sink to the seabed when they die. And over time, what happens is that these organisms and their remaining bodies, right, are actually subjected to heat from the earth and pressure. So what happens is that under all this high pressure and heat, it actually forms fossil fuels. So how do we get all these fossil fuels out? What we do is we actually construct an oil rig, or what we call a deep well. Actually drill deep down into the seabed, and from the bottom of the seabed, extract out the petroleum and natural gas upwards to the sea level. And from there, you can actually get the normal crude oil or petroleum. Then you bring it to the factory for refinery before you sell it out to, say, places like your petrol stations. So this is how fossil fuels actually come about and how they are being obtained. Natural gas and petroleum are the main sources of energy that we use. So natural gas is actually the cleanest form of fossil fuel, and it's mainly made out of methane. So methane, according to what you learned last time, it has this formula of CH4. Okay, about 70 to 90% of natural gas is actually methane. But the one that we usually spend more time to talk about in this chapter is petroleum. So petroleum also has a name known as crude oil. Okay, do not confuse petroleum with the term petrol. Okay, they're actually different chemicals, different substances. So petroleum is a mixture of what we call hydrocarbons. So hydrocarbons, if you look at the term itself, you'll see hydrogen and carbon. So what this means is that inside petroleum, there's made of many compounds that has carbon and hydrogen atoms within it, right? So these are known as hydrocarbon. So a petroleum is actually a mixture of hydrocarbons, like what I mentioned just now, and it's actually quite useless if you don't separate them out into the individual components. So how do we separate them out? First and foremost, we need to understand that inside petroleum, the hydrocarbon can have different number of carbon and hydrogen atoms. Because of that, they will have different molecules. For example, if there's one hydrocarbon that has a lot of carbon, it will tend to be heavier as compared to one that has very little carbon. This difference in molecular mass will eventually result in different boiling point. A fraction with fewer carbon atoms will be lighter and therefore has a lower boiling point range compared to one that is heavier. And the heavier ones will then have a greater boiling point. So what this means is that inside petroleum itself, you have many different hydrocarbons. And these many different hydrocarbons, they have a range of boiling point. Now, if they have a range of boiling point, do you know how we can separate them out into the individual component? You've learned this method actually at the start of last year in Sec 3. And this is actually none other than fractional distillation, which separates components based on their different boiling points. So petroleum can be separated by fractional distillation, but this is not your normal fractional distillation that you use at home or use in the lab. So what I'm going to show you now is a short clip that highlights to you how fractional distillation is carried out to petroleum, or what we know as crude oil, in a larger scale, so as to separate them out into individual components. Do pay attention to the individual components as well as the uses of them, because that is one of the key components of this entire chapter, which is to know which components come out at which part and what are the uses of these respective components.
In this video, you will learn how fractional distillation separates crude oil into useful fractions. Crude oil is the term used to describe unprocessed oil. That is oil that has been taken directly out of the ground, either on land or under the sea. It is an exceptionally valuable resource. It provides us with a great number of hydrocarbons, some of which are useful as fuels, and others are used in the manufacture of many different chemicals and even plastics. However, in the raw form as crude oil, it can be a viscous, dark-coloured tar-like consistency, and the different fractions of hydrocarbons must be separated by fractional distillation for them to be useful. Before we understand how fractional distillation works, we should be clear that crude oil is a mixture of hydrocarbons with different chain lengths, some being short molecules and some being very long. Intermolecular forces act between molecules, and the longer the molecule, the greater the intermolecular force. As you can see here, the small molecules have weaker intermolecular forces, and so will require less energy to break them apart and turn them into a gas. They have a lower boiling point. The longer molecules have greater intermolecular forces. More energy is required, a higher temperature will be needed to evaporate these molecules. They have a higher boiling point. Now we understand how chain length is related to the boiling point of a molecule. Let us look at how this method works. As you can see, crude oil is heated up to a high temperature outside of the fractionating column. The hot crude oil, now mostly in vapour form, is pumped into the column. The column has a heat gradient and is very hot at the bottom, going cooler as we move up to the top. Even at the very bottom of the column, where the temperature is still high, some long chain molecules with high boiling points begin to condense back into a liquid. These are collected at the bottom of the column. The rest of the molecules start to rise up the column, making their way through bubble caps in each tray. The bubble caps slow down the rate of the rising vapour, and eventually the vapours get too cool, condense, and are collected as liquids in the trays. Small molecules have low boiling points, and so condense much higher in the column, where the temperature is cooler still. As you can see, hydrocarbons with similar boiling points are collected in the same tray, and this is why they are known as fractions. They are mixtures of hydrocarbons with similar boiling points. Each fraction has some important uses. Some examples of fractions are petrol, useful as a fuel for cars, naphtha, used in the manufacture of chemicals, kerosene as aircraft fuel, diesel oil, used as fuels for vans, cars and lorries, and bitumen, a mixture of large chain hydrocarbons used to lay roads. Now, at the end of this video, you should understand that crude oil is a mixture of important hydrocarbons, and that fractional distillation is the method used to separate crude oil into useful fractions with similar boiling point. You should understand that small chain molecules are collected at the top of the column since they have lower boiling points, and larger chain molecules are collected further down the column as these have higher boiling points.
So, as you saw in the video, in a fractionating column that's used to separate petroleum, petroleum is first passed into a furnace. Within the furnace itself, it's actually being heated up. Heated up so that when it enters the furnace itself, it will become a vapor form. And then the vapor will pass into the fractionating column. Within the fractionating column, what happens is that vapors that has a lower boiling point, they will actually rise to the top of the fractionating column, and they will come out, and usually they are collected as gas. So that's where you get your petroleum gas. Vapors that have a higher boiling point, they tend to not boil that easily, and what happens is that they are usually collected at the bottom of the entire fractionating column, and they are known as the residue. So what happens is, as you go through this entire separation, you end up separating them into various useful components, such as petroleum gas, which has the lowest boiling point at the top of the column, followed by petrol, naphtha, which is used as a chemical feedstock for various drugs and chemicals, kerosene, which is also known as paraffin, Kerosene is different from petrol because they are being used for aircraft engines. Diesel oil are also different from petrol because they are being used for larger vehicles such as buses, lorries and trains. You have your lubricating oil, which is used to lubricate machines, make waxes and polishes. And last but not least, you have your bitumen. Your bitumen is this sticky fluid chemical that's being used to make road. Okay, so if you recall, a few chapters earlier, you also learned about a certain material that can be used for making of roads. Okay, and in fact, this bitumen is being combined with the other component, which is known as slag, which you get from extraction of iron. Together, they will be used to make the road surface that you see. So what we see over here is that whatever is being obtained at the top of the fractional column, they actually have very low boiling. Whichever that's obtained at the bottom one will actually have high boiling point. And this has to do with their size, the mass, how many carbon and hydrogen they have. Bitumen has a lot more carbon and hydrogen, and therefore it has a higher boiling point. Now, what is the importance of knowing that? Because in the real world, lighter fractions actually have higher demand, whereas heavier fractions have lower demand. So what this means is that while we can separate the entire petroleum into different components, some components will be more demanded than the rest. And what we do is, instead of keeping a lot of the large fractions, which are quite useless because there's not a lot of demand for them, like bitumen or this, what we do is we can actually use this process called cracking to form smaller hydrocarbons. So such as what we call alkenes and alkenes, and even hydrogen gas. Okay, we'll cover this in greater details. So cracking, right, is really like if you take a piece of biscuit and you crack it into smaller pieces. But in order to do that, you need heat and you need catalyst. So a catalyst helps to speed up the reaction so that you can obtain what you want at a faster time. So what I'm saying over here is that instead of having bitumen, which is a large fraction, I can actually make it go through cracking to form various small components such as petrol, maybe even kerosene, maybe even naphtha. And then since naphtha, kerosene and petrol are more useful, I can be able to sell them out for more money rather than keeping the bitumen, which not a lot of people want. Right? That's the purpose of you doing cracking. Now that we have mentioned so much about how to obtain petrol and how we can even do cracking to get smaller pieces of hydrocarbons, we need to understand what exactly are the environmental issues that can arise from the use of fossil fuels. Because as you know, fossil fuel is a non-renewable resource, which means that one day you'll be used up or you'll be depleted. So non-renewable resources are also what we call limited and finite resource. So finite means that they can be used up one day. Another problem is that whenever we burn fossil fuels, we actually causes pollution because fossil fuels contain carbon, and you know that combustion of carbon containing fuels, if it's incomplete, it actually produce pollutants such as soot, carbon monoxide and even unburnt hydrocarbon. And you should know that carbon monoxide can do certain things to our red blood cells, which affect our ability to breathe. And unburnt hydrocarbon can also react to cause a lot of problems. In fact, in fossil fuels, sometimes there are also sulfur impurities. And when you burn all these fossil fuels that contain sulfur, what happens is that the sulfur will react with oxygen and it give you sulfur dioxide. And this sulfur dioxide can then give rise to acid rain. Now, do you still remember what are the harmful effects of acid rain? Because one of the main things is that acid rain can actually cause corrosion of buildings that are made of limestone. It can even affect the water bodies by lowering the pH, then causing the fish and the other plants to die. Despite being a finite resource and causing pollution, these are not just the only problems with fossil fuels. One of the key challenges that we have right now is because fossil fuels, especially petroleum, they are not only used to provide us with energy, but it's because it's also important as a chemical feedstock. That means a lot of the medicine that you take today, such as Panadol, cough syrup or other kind of flu medicine, etc., they actually requires a certain fraction within the petroleum to be made. For example, naphtha is usually used to make chemicals that we are using nowadays. Therefore, every time when you use up petroleum for other purpose, you're actually reducing the amount they can use to make useful medicine that can save a lot of lives. Now, how can we do something to resolve this issue? First, if you want to address the problem of pollution by air pollutants from the burning of fossil fuel, we actually need to go back and take a look at what we learned in the chapter on air. Because for carbon monoxide, unburned hydrocarbon, sulfur dioxide, these are all called air pollutants, and there are various ways to treat all these air pollutants. Maybe using catalytic converter, for example. So what I will need you to do is to go back and look at the notes on the air chapter, try to refresh your memory and link these two chapters together by filling in the blanks. So that's the problem on pollution. But how can we address the problem of fossil fuels being a non-renewable and finite resource? Well, first of all, we can use hybrid technology. We can use hydrogen fuels in cars. So instead of using burning fossil fuels, or rather burning petrol, we can actually use electric car, like what you see over here, Blue SG, which is running around in Singapore right now. One other thing that we can do is to conserve the use of petroleum. So rather than using motor vehicles out there, we can actually take public transport such as buses and MRT. By doing that, we actually reduce the amount of fuels that we burn and help to safeguard the amount of petroleum that we have. Another way, we can use alternative fuel. So those of you who are interested in energy and green chemistry, you know that there's something that's coming up quite rapidly is your green energy. So for instance, using solar energy, using things like biodiesel, using things like solar roof, biofuel, so using plants and sugar cane, all these things to make petrol instead. Or even in certain places around the world, they're using hydroelectric energy, which is to use a water dam to obtain the energy from the water. So all these are various ways that we can do to reduce our reliance on fossil fuels. But of course, at the end of the day, we understand that in order for us to stop relying so much on fossil fuel, there needs to be certain trade-off and certain changes in lifestyles. Alright, to consolidate what we went through in this entire topic, what happened is that we actually started off the lesson by talking about what exactly are fuels. So fuels actually go through reactions like combustion to give you energy. These are exothermic reactions. Next, we talk about fossil fuels, and in particularly, we talk about petroleum by highlighting how are they being separated based on the boiling points, whereby the lower boiling point substances are being obtained at the top part of the column and the higher boiling point ones are at the bottom part of the column. Through that, we mentioned that the different components, there's a better way to remember them, and we can arrange them from top to bottom. Each of them, there's a certain function for them. Next, we mentioned a bit about cracking. So you'll see this term called cracking again in the next few chapters. But basically, the idea is to take a larger piece of substance and break it up into smaller pieces. And last but not least, we mentioned about what are some of the environmental issues that can arise from the use of fossil fuels and what are the possible solutions for them. And with that, we have come to the end of this chapter. See you back in class.